This is our world, our land, our home. It nourishes us, protects us, amazes us. But it is at risk. Humans, through the energy we use, the ways we live, produce food, and use our land, are affecting the global climate. The land surface is warming faster than the globe on average. Every degree matters to limit global warming and reduce the impacts of climate change. How can we achieve this? The IPCC Special Report on Climate Change and Land explores how the way we use our land is contributing to climate change and how climate change is affecting our land. The report is one of the most comprehensive records on the interactions between climate change and land to date. Experts from around the world have been working together to assess the best state of knowledge, looking at trends, regional and global hotspots, solutions, risks, consequences and benefits, and anticipating the future to help us address and adapt to climate change. The land we use today will affect the climate for generations to come and the challenges we face, from maintaining a balanced Earth to the security of our food and livelihoods. The way we use our land and the way we live will help to secure our future.
Good afternoon and welcome to this special event organized by the SBSTA and the IPCC to look at and to understand better the special report on climate change and land produced by the IPCC a few months ago. So I very much want to welcome you to this special event this afternoon. I particularly want to thank my co-chair, Ho-Sung Lee, the chair of the IPCC, and we will be running this event throughout the afternoon, taking turns to chair our work. I want also to thank Patricia Espinosa, the UNFCCC Executive Secretary, for joining us for the opening of our discussion this afternoon. This joint special event will provide an opportunity to hold an open exchange between IPCC experts and participants in the new scientific knowledge and key findings of the IPCC Special Report on Climate Change and Land. The role of science in the UNFCCC process is vital in helping the world to understand the seriousness, the causes, the impacts of climate change, in assessing the uncertainties and gaps in our knowledge of climate change, but also to help us move forward and to inform our action. And I have to stress the fact that we go from understanding the causes and the impacts to also understanding what we can do. I think it is important to see all of those. So on behalf of SBSTA, I would like to convey my gratitude to the IPCC, which has served continuously as a trusted provider of the best available science over many years now. For longer than we have been around, since you celebrated your 30 years last year. Sadly, 30 years when we have not solved the climate crisis, as we know. Nonetheless, throughout that time, our knowledge and information has improved enormously, and the role of the IPCC has been critical. So thank you, and you are a key partner to us as SBSTA and in the UNFCCC process. So we'd like this event this afternoon to help participants, parties, observers, all of you, generate a better understanding of the key scientific findings of the IPCC Special Report on Climate Change and Land. In return, we hope that this event could assist the IPCC and the scientific community in identifying areas of interest to policymakers to be further developed in future IPCC products. The event today is being webcasted. That's why we're using this very big room, and it seems a bit cavernous, I'll be honest. Many of you are sitting at the back. Seats are reserved for parties, but there is space for others to take place as well, so please use it sensibly. But this room allows us to have webcasting to allow others outside the room to benefit from the presentations and the ensuing events. And of course, all the presentations will be online on the website, on the webpage of SBSTA related to this event. So I'd like to remind you that Ho-Sung and I will also organize a similar joint event to unpack the findings of the Ocean and the Cryosphere Special Report tomorrow in the afternoon in this same room. So let me say a few words briefly about today's event. And I'm firstly extremely grateful to the IPCC for agreeing to organize this event with SBSTA. I think it is very important that we take time to understand the products, the very important products that so many people, so many in the scientific community have spent a lot of time and effort putting together. And I want to thank you for that. Today's special event is focused, as I said, on the special report on climate change and land. We published a few weeks ago, on the 6th of November, an information note to provide some background information and to propose an agenda for this event. That note is on the UNFCCC webpage, cooperation with the IPCC. Now, guided by the storyline of the summary for policymakers of the special report, the IPCC working group, the co-chairs of the IPCC working groups, will make presentations on the special report, focusing on new scientific findings and their context. We urge the presenters, when giving their presentation, to the extent possible, to address the questions which are included in our information note. And I'm certain they will be happy to respond to questions from the floor on the relevant topics. And I want to make this an interactive event. It's hard in this room, but let's make it so. So the first round of presentations will be given by Valérie Masson-Delmotte, co-chair of IPCC Working Group 1, and Hans-Otto Pörtner, co-chair of IPCC Working Group 2. And they will focus on the interaction between land, people, and climate in a warming world. We'll then move into a second session and listen to presentations on adaptation and mitigation response options, with presentations from Pan Mao Jai, co-chair of IPCC Working Group 1, and Jim Skier, co-chair of IPCC Working Group 3. Finally, we'll have a third session on enabling response options and action in the near term, bringing together those two elements. And it is Deborah Roberts, co-chair of IPCC Working Group 2, who will make a presentation to introduce that discussion. After each round of presentations, you will have the opportunity to ask questions on the relevant topics. In addition to the IPCC co-chairs, I'm delighted that a number of IPCC experts and authors have generously agreed to be available, and they will step in as needed during our discussion to provide some further detail in the responses to questions that may be raised, and to respond also to some points raised by the co-chairs if need be. I'm keen to ensure that this event remains an interactive learning experience to help us all better understand the key findings of the IPCC special report. And in that regard, I would like to invite all parties and observers, when you intervene from the floor, to keep your interventions succinct and focus on questions on the findings of the report. And Ho-Sung and I will sum up, provide some summing up comments at the end of this afternoon's event. So, without further ado, I would like to invite Patricia Espinosa, the UNFCCC Executive Secretary, to provide some remarks before we begin the first session. Patricia, you have the floor.
Thank you very much. And I want to start by thanking Paul Watkinson, the SBSTA chair, and Mr. Ho-Sung Lee, the IPCC chair, for organizing this special event, one that I am convinced will help parties and all of us to better understand the content of the report. My gratitude also goes to the IPCC vice chairs, the co-chairs of the IPCC working groups, experts, and all participants for taking the time of these very busy schedules to engage in this open dialogue. These are really busy schedules indeed, and I myself want to apologize already now because I will have to to leave shortly after I have spoken, so please bear with me. The IPCC, during its 6th assessment cycle, has produced 3 special reports in just over a year. The special report on 1.5 degrees, this report on climate change and land, and the report on the ocean and cryosphere. The IPCC also produced the 2019 refinement of the 2006 National Inventory Report Guidelines. On behalf of the UN Climate Change Secretariat, I convey my sincere gratitude to the IPCC for this vital work. It's yet another confirmation of the value of science to this process and its contribution towards our collective efforts to address climate change. People are increasingly witnessing the impacts of climate change, regardless of where they live. But we cannot work by observation alone. The science must be central and paramount in our work. We must be guided by the facts, not instincts. And what the facts are telling us is that we are severely impacting the very support systems that keep us alive on this planet. If we are to change this, we must, at all sectors of society, work to make a necessary transition to new and more sustainable ways of living and planning for the future. Let's turn to the importance of this specific report. Like other IPCC work, it provides the best available scientific basis for the work under the UN climate change process. And in that process, land is a vital sector, and most NDCs include commitments to it. This is because land-based solutions have the potential to reduce emissions. Properly managed land can serve as a sink that can contribute to achieving a balance between emissions and carbon sinks. These have the potential to provide about 1/3 of the additional mitigation that is needed by 2030 to close the gap between current trajectories based on the NDCs and what parties agreed to in the Paris Agreement. Let us not forget that land is equally important when we consider adaptation responses as well. We cannot simply look at mitigation alone. The report is also relevant to all 3 Rio Conventions and raises important questions on synergies between them in the context of sustainable development and poverty alleviation. I am looking forward to exploring these synergies during the course of this special event. But how does all this impact the negotiations and the parties? In addition to informing discussions on agenda items under the UNFCCC, the much-awaited 6th assessment report will provide the scientific basis for the 2nd periodic review of the long-term goal on temperature under the Convention and the first global stocktake of the Paris Agreement. So this special report on climate change and land is timely, and its content allows parties to draw from it with respect to updating and communicating their NDCs for the 2020 deadline. These NDCs are only submitted every 5 years, and we know that if we don't act within this time period, we risk missing any chance of achieving our overall climate goals under the Paris Agreement. So let's get to the details of this report now, and I would like to turn things back over to the organizers. Before I do, I want to once again thank all involved. If we are to truly thank the authors, however, we can't just acknowledge the report. We must act upon it. As the next speakers will tell us, we simply have no more time to waste. And I look forward to hearing about your exchanges this afternoon. Thank you very much.
Thank you very much, Patricia, for your remarks, and we understand you won't be able to stay with us for the whole of this afternoon's work. But I understand myself how difficult that is, but I think it is very good that you were able to join us for the opening, and I can only underline the centrality of science for our work under the convention process, and obviously for SBSTA, that is a particular side, having the best available science, and our work with the IPCC has been where we've really been turning to have that, and we've had that with the special reports we have been delivered over the past year. With that, I would like to hand over and give the floor to my co-chair, Ho-Seung Lee, to provide his opening remarks, and he will then introduce the first set of presenters and moderate the ensuing question and answer session. Ho-Seung, over to you.
Thank you very much. Thank you, Patricia and Paul, for the introduction. And I'm very pleased to open the presentation of the IPCC Special Report on Climate Change and Land at this important SBSTA-IPCC special event. As Patricia just mentioned, climate change and land is one of 3 reports IPCC has released this year, besides the ocean and cryosphere in changing climate, and which will be presented in another special event tomorrow here. And the update to our methodologies with the 2019 refinement to the 2000 IPCC guidelines for national greenhouse gas inventories. Incidentally, these 3 reports, along with advancing work on the 6th assessment report itself, make this year the most intensive year in our history. Climate change and land and the 2019 refinement methodology report complement each other in important ways. And the 2 special reports come together with last year's special report on global warming, 1.5 degrees Celsius, to assess 2 key components of the climate system in the context of emissions pathways. Over 2 years in the making, the special reports on climate change and land explores how the way we use our land contributes to climate change and how climate change affects our land. Just a very few brief remarks about the inputs for the production of this important special report. I want to highlight that. This special report was prepared by 107 leading scientists from 52 countries across all regions of the world who acted as coordinating lead authors, and review editors. 40% of coordinating lead authors are women, and 53% of authors are from developing countries, making this the first IPCC report to have more authors from developing countries than from developed countries. Over 7,000 scientific publications were assessed in this report. And under the IPCC's rigorous and open preparations process, the report received a total of 28,275, to be exact, review comments from expert reviewers and governments. We can summarize the work in a very few simple words. The land is under growing human pressure, land is part of the solution, and land cannot do it all. The special report on climate change and land consolidates 6 proposals from our member states and observer organizations related to land when we sought proposals for special reports at the start of this assessment cycle. These six proposals were brought together in a single report whose full title reflects the range of topics assessed: climate change and land, an IPCC special report on climate change, desertification, land degradation, sustainable land management, food security, and greenhouse gas fluxes in terrestrial ecosystems. These topics intersect with complement assessments and studies being conducted by other intergovernmental bodies. And so the IPCC organized 3 web-based consultations with IPBES, FAO, and UNCCD before we held our own scoping meeting for the report. The conclusion was that the IPCC should keep the focus on the land-climate nexus and not duplicate the work of other organizations. I would like to conclude by showing you the cover of the report. which matches those of other special reports in this cycle. For this report, a photograph was sourced from the photographer and artist Bertrand, taken in Turkey. This striking image shows the land above. It is important in the context of the special report as the image represents a mixture of terrains and purposes that land has on our diverse planet. We will now move to a substance of today's event, unpacking the new scientific knowledge and key findings. Let me briefly summarize key findings in 4 capsules. This report again confirms that the need for immediate reduction of greenhouse gas emissions. Second, failing that would mean a further degradation of land. That means increased threat to food security, biodiversity, and ecosystem services. And there will be very little room for ecosystem-based adaptation and sustainable land management, as these adaptation options are effective only under the low-emission pathways. I'd like to hand over now to Valérie Vasson-Metton, the co-chair of Working Group 1, and Hans Otto Partner, co-chair Working Group 2, who will take you through the topics covered by the first section for the summary for policymakers, people, land, and climate in a warming world. You have the floor.
Thank you, Ho-Sung. In this report, land refers to soil, vegetation, and other living organisms, water, as well as our settlements and infrastructures. Land provides the principal basis for our livelihoods and well-being, including the supply of food, fresh water, and multiple other ecosystem functions and services that are essential to us, as well as biodiversity. For instance, the world's terrestrial ecosystem services have been valued on an annual basis to be approximately equivalent to the annual global gross domestic product. But land is under growing human pressure, with unprecedented rates of land and freshwater use. Human use directly affects around 70% of the global ice-free land surface. The expansion of areas under agriculture and forestry and enhanced productivity have supported food availability for a growing population and changes in consumption. The potential net primary production is the difference between the amount of carbon accumulated through photosynthesis and lost by plant respiration in the absence of our land use. We currently use 1/4 to 1/3 of this land's potential net primary production for food, feed, fiber, timber, and energy. These changes have contributed to the loss of natural ecosystems, such as forests, savannas, natural grasslands, and wetlands, and declining biodiversity. As a result, about 1/4 of the Earth's ice-free land area is subject to human-induced degradation. Soil erosion from agricultural fields is estimated to be currently 1 or 2 orders of magnitude higher than the soil formation rate, depending on tillage practices. Data available since 1961 show that the global population growth and changes in per capita consumption of food, feed, fiber, timber, and energy have caused unprecedented rates of land and freshwater use. This is illustrated on the left panel. Since 1961, the total number of ruminant livestock has increased by more than 50%. The growth in cereal yields has been supported by sharp increases in the use of inorganic nitrogen fertilizer by nearly 9-fold, and irrigation water, which has roughly doubled. Climate change is adding to these pressures on land. Since the pre-industrial period, 1850 to 1900 in this report, the observed mean land surface air temperature has risen considerably more than the global mean surface, over land and ocean temperature. Over land, the surface air temperature has increased by 1.53 degrees Celsius, and you see the very likely range on the screen, while at the global scale, it has increased by 0.87 degrees Celsius. Warming has resulted in an increased frequency, intensity, and duration of heat-related events, including heat waves in most land regions. The frequency and intensity of droughts has increased in some regions, including the Mediterranean, West Asia, many parts of South America, much of Africa, and Northeast Asia. And there has been an increase in the intensity of heavy rainfall events at a global scale. Global warming has led to shifts of climate zones in many world regions, including the expansion of arid climate zones and the contraction of polar climate ones. As a consequence, many plant and animal species have experienced change in their ranges, abundances, as well as shifts in their seasonal activities. Vegetation greening is observed by satellites over the last 3 decades in parts of Asia, Europe, South America, Central North America, and Southeast Australia. Causes of greening include combinations of a longer growing season, nitrogen deposition, irrigation, CO2 fertilization, and land management. Vegetation browning has been observed in other regions, including Eurasia, parts of North America, Central Asia, or the Congo Basin, largely as a result of water stress. So far, vegetation greening has occurred over a larger area than browning. In some dryland areas, increased air temperature and evapotranspiration, as well as decreased precipitation amounts, in interaction with climate variability and human activities, have contributed to desertification. These areas include sub-Saharan Africa, parts of East and Central Asia, and Australia. Since 1961, the annual area of drylands in drought has increased on average by more than 1% per year, but with large interannual variability. About 500 million people live within areas which experienced desertification in the last 30 years. The highest numbers of people affected are in South and East Asia, around the Sahara, including North Africa, and in the Middle East. The frequency and intensity of dust storms has increased over the last few decades due to land use and land cover changes, as well as climate-related factors in many dryland areas, with increasingly negative impacts on health. And finally, climate change exacerbates land degradation, particularly in low-lying coastal areas, river deltas, drylands, and in permafrost areas, due to changes in rainfall intensity, heat and water stress, permafrost thaw, coastal erosion, and sea level rise. The food system is under pressure due to population growth and changes in consumption patterns, and it is vulnerable to climate change. For instance, data since 1961 show the per capita supply of vegetable oils and meat has more than doubled, and the supply of food calories per person has increased by about a third. Currently, a quarter to a third of total food produced is lost or wasted, depending on regions. An estimated 8 million and 21 million people are still undernourished. Changes in consumption patterns have contributed to about 2 billion adults now being overweight or suffering from obesity. Climate change has already affected food security due to warming, changing precipitation patterns, and greater frequency of extreme events. In many lower latitude regions, yields of some crops, for instance maize and wheat, have declined, while in many higher latitude regions, yields of some crops have increased over recent decades. Climate change has resulted in lower animal growth rates and productivity in pastoral systems in Africa. There's robust evidence that agricultural pests and diseases have already responded to climate change, resulting in both increases or decreases of infestations. And based on indigenous and local knowledge, climate change is affecting food security in drylands, especially in Africa and in high mountain regions of Asia, as well as South America. Land plays a key role in the global climate system. Changes in land conditions affect global and regional climate through fluxes of greenhouse gases, energy, water, aerosols between the land surface and the atmosphere. Agriculture, forestry, and other land use activities have accounted for around 23% of total net anthropogenic emissions of greenhouse gases, or 12 plus or minus 3 billion tons CO2 equivalent per year during the period 2007 to 2016. Global models estimate net CO2 emissions of around 5 billion tons CO2 per year. For that period, that's about 30% of total CO2 emissions. They are mostly due to deforestation, partly offset by afforestation or reforestation. And there's no clear trend in these emissions. For methane, the I4U sector accounts for 44% of methane emissions in that period. Ruminants and the expansion of rice cultivation are important drivers to the ongoing rise in atmospheric methane concentration. The nitrous oxide emissions from this sector are rising and represent 82% of total emissions. Anthropogenic nitrous oxide emissions from soils are primarily due to nitrogen application, including inefficiencies. There has been a major growth in emissions from managed pastures due to increased manure deposition. And livestock on managed pastures and rangelands accounted for more than 1/2 of total nitrous oxide emissions from agriculture. If emissions associated with pre- and post-production activities in the global food system are included, then the emissions from the total food system are estimated to reach 21 to 37% of total net greenhouse gas emissions linked with human activities. Emissions from the food system are projected to increase, driven by population and income growth and changes in consumption patterns. Land is both a sink and a source of CO2 due to anthropogenic and natural drivers. The natural response of land to human-induced environmental changes, such as increasing CO2 concentration, nitrogen deposition, and climate change, has resulted in global net removals of around 11 billion tons CO2 per year, again from 2007 to 2016, which represents around 29% of total CO2 emissions from all sectors. This report stresses that global models, bookkeeping models, and national greenhouse gas inventories use different methods to estimate CO2 emissions and removals from the land sector. The methods are in close agreement for land use change involving forests, but differ for managed forests. Consideration of differences in methods can enhance understanding of land sector net emission estimates and their applications. Future net increases in CO2 emissions from vegetation and soils due to climate change are projected to counteract increased removals due to CO2 fertilization and longer growing seasons. The balance between these processes in the future is a key source of uncertainty for the future of the land carbon sink. The potential of increasing soil carbon decreases as climate change intensifies, as soils have reduced capacity to act as sinks for carbon sequestration at higher temperatures. And finally, projected continued thawing of permafrost is expected to increase the loss of soil carbon in these regions. However, during the beginning of the 21st century, vegetation growth in those areas may in part compensate for this loss. And with this, I pass over to Hans. Sorry, go ahead.
To complete this story, changes in land conditions, either from land use or climate change. Is this done already, this one? Can we go back one? Affect global and regional climate. At the regional scale, changing land conditions can reduce or accentuate warming and affect the intensity, frequency, and direction of extreme events. drier, wetter soil conditions can increase or reduce the severity of heat waves. And when forest cover increases in tropical regions, cooling results from enhanced evapotranspiration. Now we are moving to looking at the impacts of climate change. And climate change exacerbates existing risks to livelihoods, biodiversity, human and ecosystem health, infrastructure, and food systems. Increasing impacts on land are projected under all future greenhouse gas emissions scenarios. Some regions will face higher risks, while some regions will face risks previously not anticipated. With increasing warming, the frequency, intensity, and duration of heat waves, droughts, and rainfall are expected to increase in many regions. Climate zones are projected to further shift poleward in the mid and high latitudes. In high latitude regions, warming is projected to increase disturbance in boreal forests, including drought, wildfire, and pest outbreaks. And in tropical regions, under medium and high greenhouse gas emissions scenarios, warming is projected to result in the emergence of unprecedented climatic conditions by the mid to late 21st century. Now, in order to capture the risk levels associated with the impacts of climate change, we have done risk assessment. And the risk assessment uses a color code, going from undetectable to moderate to high and to very high risk. The white color reflects impacts and risks are undetectable. The yellow color reflects that impacts and risks are detectable and attributable to climate change with at least medium confidence. The red color reflects significant and widespread impacts and risks, and the purple color reflects very high probability of very severe impacts and risks and the presence of significant irreversibility or the persistence of climate-related hazards combined with limited ability to adapt due to the nature of the hazard of impacts or risks. And on the right-hand side, you see how we indicate the confidence level for the transition between risk levels. As an example, you see on this slide depicted the risks for wildfire damage and for food supply instabilities. And to reflect the risk level associated with that, you see insets which qualify the processes concerned and indicating that risk. So for medium risk under wildfire damage, you see an increase in fire weather season as already observed in many regions under current temperatures. The high risk level reflects that, for example, over 50% increase in area burned in the Mediterranean region. And the very high risk level is reflected when over 100 million people are additionally exposed to wildfire damage. On the other side, food supply instability at moderate risk are indicated by food shortage causing infrequent price spikes which affect individual countries. And the high risk level is reflected by periodic food shocks across region, whereas the very high risk level is reflected by sustained food supply disruptions globally. And the calibration scale for all of these risks is the global mean surface temperature relative to pre-industrial times. When we move to the next slide, we see that the risk categories distinguish those risks that are associated with desertification compared to land degradation or in the risk levels associated with food security. And the current levels of global warming, as indicated by the grayish bar on the temperature scale, are associated with moderate risks from increased dryland water scarcity, soil erosion, vegetation loss, wildfire damage, permafrost thawing, coastal degradation, and tropical crop yield decline. At around 1.5 degrees of global warming, the risks from dryland water scarcity, wildfire damage, permafrost degradation, and food supply instabilities are projected to become high. At around 2 degrees of global warming, the risk from permafrost degradation and food supply instabilities are projected to be very high. And at around 3 degrees of global warming, risk from vegetation loss, wildfire damage, and dryland water scarcities are also projected to become very high. So there is an escalation of risk levels. Risks from droughts, water stress, heat-related events such as heat waves and habitat degradation simultaneously increase between 1.5 degrees and 3 degrees of global warming. Under one of the shared socio-economic pathways, and we will get to that in a little while, the dryland population vulnerable to water stress, drought intensity, and habitat degradation is projected to reach 178 million people by 2050 at 1.5 degrees global warming, 220 million people at 2 degrees global warming, and 277 million people at 3 degrees of global warming. Now let's look into how actually for the same level of risk, the level of warming, the level of risk depends on the choice of development. And here on this graph, we are distinguishing two shared socio-economic pathways, SSP1 and SSP3. What you see that SSP3 consistently comes with the onset and the earlier transition to higher risk level. Earlier meaning at lower global mean surface temperature. The stability of food supply is projected to decrease as the magnitude and frequency of extreme weather events that disrupt food chains increases. And in these scenarios, the most vulnerable people will be more severely affected. In drylands, climate change and desertification are projected to cause reductions in crop and livestock productivity, modify the plant species mix, and reduce biodiversity. So there are benefits associated with the SSP1 scenario as clearly indicated by this slide, and that makes it worth to look at the characteristics of those SSP scenarios. And in SSP1, there is low population growth, remaining at about 7 million people by 2100, reduced inequalities, low emission production systems, efficient use of land, increased capacity for adaptation. Whereas, and this contrasts then SSP3, where there is increased population, up to 13 million people, and demand, increasing inequality, multiple pressures on land, and low capacity for adaptation. Now let's also look at the regions, and here are some messages for those different places. In North America and South America, Mediterranean, Southern Africa, and Central Asia, these places may be increasingly affected by wildfire. Asia and Africa are projected to have the highest number of people vulnerable to increased desertification. And the tropics and subtropics are projected to be most vulnerable to crop yield decline. So emphasizing again the different pathways of development that are ahead of us, the level of risk posed by climate change depends both on the level of warming and on how population consumption, production, technological development, and land management patterns evolve. And here I would like to summarize some of these findings under this heading. Pathways with increased population and income result in increased demand for food, feed, and water in 2050 in all shared socio-economic pathways. Together with resource-intensive consumption and production and limited technological improvements in agriculture yields, this results in higher risks from water scarcity and food insecurity. These changes have implications for terrestrial greenhouse gas emissions, carbon sequestration potential, and biodiversity. And further, I'm summarizing that risks are higher in pathways with low adaptive capacity and other barriers to adaptation. Risks related to food security are greater in pathways with lower income, increased food demand, increased food prices, resulting from, for example, competition for land and more limited trade. As a final point, urban expansion is projected to lead to conversion of cropland, leading to losses in food production. This can result in additional risks to the food system. With that, I'm concluding this section of the presentation.
Thank you very much, Valerie and Hans, for the good presentation. I'd like to open the discussion and invite questions from the floor on this part of the presentations. Due to time constraint, we will have 15 minutes for Q&A. Floor is open. Germany, you have the floor.
Thank you. Germany, and I'm speaking also as a member of the EU, we strongly welcome the IPCC Special Report on Climate Change and Land as an important, authoritative and timely scientific assessment. We welcome the opportunity to participate in the SBSTA-IPCC special event, and we heartily thank the scientists involved for providing important and timely information in support of our work here under the Convention. This report and also the report on the ocean and the cryosphere complement the IPCC special report on 1.5 degree global warming by adding more detailed information on land-related issues. We are looking forward to considering and understanding the knowledge presented by the IPCC in its recent reports under all relevant agenda items. And now comes my question. Climate change leads to geographical shifts of species, both flora and fauna. And those who can move to cooler regions, they go towards the poles and upwards in the mountains. The report, however, does not indicate extinction of species. Could you please elaborate a bit on the effect of climate change on biodiversity and related ecosystem services? Thank you.
Thank you very much. We will take 2 more questions, and then I will invite the co-chairs to respond. Sierra Leone and then Luxembourg. Sierra Leone, you have the floor.
Okay, thank you very much for the extreme valuable presentation. Of course, Sierra Leone takes the floor on behalf of the LDC group. The new emblematic figure of the burning embers, of course included in the figure, constitutes a clear illustration of the fact that the risk to humans and ecosystem on land increase as the global mean temperature is rising. Anyway, please correct me if this is to be understood differently, but the burning embers appears to tell us that food supply will be subject to very high risk if we exceed between 1.5 and 2.5 degrees Celsius of the global warming. This would mean that there will be sustained food supply disruption globally with significant irreversibility of the related hazards and a limited ability to adapt. Given that another burning embers indicates that tropical crops are put at high risk for a global warming level of more than 1.5 to 2 degrees Celsius, that brings me to the question that which region will be most vulnerable to this sustained food supply disruption, and which regions will be most limited in their possibility to adapt? Thank you very much.
Thank you, Sierra Leone. Luxembourg, you have the floor.
Thank you, Chair. Luxembourg welcomes the opportunity to participate in this special event, and we thank you and the Chair of SBSTA for organizing it. This is a very important event, and we are looking forward to considering and understanding the knowledge presented in this report under all relevant agenda items. Luxembourg welcomes very much the IPCC special report on climate change and land, which is an important and authoritative, timely scientific assessment of this important matter. And in particularly, we thank the scientists involved for providing important assessment to support the work of our convention here. As also said previously, we also think that this report and also the report on ocean and cryosphere very much complements the findings of the IPCC 1.5 special report. And it also highlights that, for example, climate change is projected to amplify existing stresses on land system, implying high risk for people, livelihoods, and well-being. One of the questions we would like to ask would be, what would be the consequences of delayed climate actions, in particularly to land? Thank you very much.
Thank you, Luxembourg. I would like to invite co-chairs for responses. Hans, you have the floor.
Yeah, thank you very much. I will be addressing the first question about the geographic shifts of flora and fauna, which are being observed, and this is a general pattern for all life on the planet, observed on land and in the oceans. And certainly on land there is an altitudinal movement to be observed as well as a latitudinal movement. As far as the extinction is concerned, there are only very singular reports and evidences for species to be going extinct under climate change. But there are certainly effects on abundances of species as well as on their productivity. And some of this also concerns species that are used by humans in their agriculture. So all of this reflects the specialization of life on this planet, on limited temperature ranges. And it also reflects the fact that current climate change is too fast for species to adapt, and that the displacement that we see and the movement in their biogeography is the overarching response. As to the second question, I actually have nothing to add to the appropriate description of the findings by St. Kitts and Nevis. With respect to the question, which regions are most vulnerable to the challenges to the human food system, these have been listed on the slide, which was telling us that Asia and Africa are projected to have the highest number of people vulnerable to increased desertification, considering that drought and extreme heat are the major challenges to crops. And the tropics and the subtropics are projected to be most vulnerable to crop yield decline. And wildfire is certainly also a challenge if those wildfires occur in higher frequency in food production areas. That concerns mostly North and South America.
Yeah. If I may complement these answers. So in terms of risks for habitats and living species, there were elements in the 1.5 report that have not been repeated here. So the assessment based on a meta-study was that the fraction of species projected to lose over half of their geographic range or habitats is doubling between a global warming level of 1.5 and 2 degrees, and at 2 degrees it concerns 80% of insects, 16% of plants, and 8% of vertebrates. There are more elements related to biodiversity and climate change in the IPBES report as well. This report flags the importance of disturbance increasing in boreal forests with the level of warming, including drought, wildfire, and pest outbreaks. And it flags the emergence of novel, unprecedented climate conditions in the tropics. So these are conditions which occurred nowhere during the 20th century, characterized by high temperature. And that's a reason why the climate-related stress for crop yields is particularly important in the tropics, because by the middle of this century, unprecedented conditions in terms of heat level will be encountered. With respect to the consequences of delayed actions, we have flagged in this report implications, for instance, for some of the response options associated with enhancing soil carbon storage, and challenges associated with the sustainability of the land carbon sink, both in agricultural soils, but also in other ecosystems, including permafrost areas that will be strongly affected with additional levels of warming.
Thank you very much, the Working Group 1 and Working Group 2 co-chairs for response. I'd like to recognize now St. Kitts and Nevis and Myanmar. These two questions will be the last ones for this session. And St. Kitts and Nevis, you have the floor.
Thank you, Mr. Co-Chair. St. Kitts and Nevis speaks on behalf of AOSIS. At the onset, we want to express our sincere gratitude to the IPCC for providing this special report on climate change and land. We very much welcome these latest series of IPCC special reports as a key input to the work of the UNFCCC and urge all parties to listen to the science and increase ambition. We would be specifically interested in learning what this special report on climate change and land tells us on what we can expect for the future in terms of loss and damage if we do not enhance our global efforts to stop climate change. What evidence would you say do we have that loss and damage is already occurring? Thank you.
Thank you very much. Myanmar, you have the floor.
Thank you, Chair. Regarding my quick observation on the IPCC reports, I noticed that the greenhouse gas fluxes in ecosystems. But when we look into the page, into the book, I found forests. But regarding my observations, there are two forest ecosystems: terrestrial forest ecosystem and mangrove forest ecosystem. Mangrove forest ecosystem along the forest. So that's why I like to know why you only highlight the terrestrial forest ecosystem. Thank you, Chair.
Thank you very much for the questions. I'd like to invite the co-chairs, Hans and Valerie. You have the floor to answer.
Yeah, thank you. St. Kitts and Nevis, you're asking a very interesting question. We have no evidence reported in this report about the onset of loss and damage already occurring, although Valerie has found some information there. Certainly with respect to the expanding challenge of desertification and loss of land available for agriculture. This also includes salinization effects in the small island states related to sea level rise. So the coastal land-ocean interaction issues, certainly you can count that under this issue. Valerie, can you please add?
Yes, with respect to the question of St. Kitts, I would like to point to your attention a table in the supplementary material of Chapter 5, Table SM 5.3, which lists observed climate change impacts on crop productions, fully traceable to data sources, publications, and detection and attribution methods. This is the most developed part of the assessment related to observed impacts on the food system.
Thank you very much. Thank you much for the questions and also the answers. I'd like to hand over to Paul for taking up the next items, please.
Thank you very much, Ho-Sung, and thank you very much to Valerie and Hans for that very good first session, looking at the section on people, land, and climate change. I wish we had more time for interaction and questions. It's very hard in this event to make it as interactive as we would like, but we will have further opportunities as we move through the sessions to discuss. So let us move now into our second part of the unpacking the new scientific knowledge and key findings. And this session this panel will focus on section B of the summary for policymakers as in the structure, adaptation and mitigation response options. And we will have presentations from Padma Ojai, who is the co-chair of IPCC Working Group 1, and Jim Skier, co-chair of Working Group 3. And they'll present this topic, and amongst other things, they'll address the questions in paragraph 17 of our information note on this event. And of course, then we'll come back to the questions. So Padma, Jim, you have the floor.
Thank you. Better land management can play its part in tackling climate change, but it cannot do it all. This figure shows the emissions and the removals of carbon dioxide from land that are associated with agriculture, forestry, and other land use. We can see land has double rules for emissions and the removals of carbon dioxide. Such a relationship between land and the carbon dioxide sink and source can be used for us to find mitigation solutions. There are also things we can do to both tackle land degradation and mitigation or mitigate or adapt to climate change. When land is degraded, it reduces the soil ability to take up carbon, and this exacerbates climate change. In turn, climate change will exacerbate land degradation in many different ways. This figure shows that the choice we make about sustainable land management can help reduce, in some cases, reverse these adverse impacts. This figure shows the things we already done for combating desertification in Africa, in Asia, can also bring co-benefits for mitigation and adaptation to climate change and ensure food security. Currently, more than 1/4 of the food produced is lost and wasted. If we reduce this loss and the waste, we reduce greenhouse gases emission and improve food security. With 41% of human-caused methane emissions coming from ruminant livestock and from paddy fields, dietary changes can also reduce pressure on land and reduce emissions. This report identifies 40 responses options for the land sector. We did not divide these response options into adaptation and mitigation. Most have multiple consequences in terms of adaptation, mitigation, desertification, land degradation, and food security. Instead, we used the 3 types of classification shown in this slide. First, we classify the response options according to whether they involved the management of land directly, management of the value chain that brings land-based products to consumers, or management of the wider risk faced by farmers and others. Second, we classified response options according to the magnitude of their technical mitigation potential at the global scale, noting that the global emissions are 52 gigaton CO2 equivalent. The measures with the largest potential could reduce emissions substantially. Finally, we classify response options according to their impact on competition for land. Some have no or limited impact on land competitions, while others rely on land change. There are 24 different response options that can be implemented with limited or no competition for land. Almost all response options have a positive effect on mitigation, adaptation, desertification, land degradation, and food security. The potential for land-related responses and relative emphasis on adaptation and mitigation is context-specific, including the adaptive capacity of communities and regions. While some response options have immediate impact, others take decades to deliver measurable results. The successful implementation of response options depend on consideration of local environment and the socio-economic conditions. This figure shows that there are 8 response options from agriculture perspective: increasing food productivity, agroforestry, improved cropland management, agriculture diversification, improved grazing land management, integrated water management, and reduced grassland conversion to cropland. For forest, soil, and other ecosystem, we have 11 response options based on land management. Most of above land-related options have positive effect and co-benefits. There are 9 response options based on value chain management and risk management. All the response options based on value chain management from supply, demand sides, and based on risk management have a positive impact and many co-benefits for mitigation, adaptation, for climate change, combating desertification and land degradation, and ensuring food security. Now I pass over to Jimsky, the Working Group 3 co-chair.
Okay, thank you, Pan Mao. I appear to have lost the picture. There we go. Okay, Pan Mao has talked to us in the last few slides about response options that are positive, effectively win-win options. But we also looked at 4 response options that had high mitigation potential, but also involved land use change. And once again, we looked at these 4 options in terms of their impacts on the 5 challenges related to land, to mitigation, adaptation, desertification, land degradation, and food security. And for each of these, rather than having one set of impacts, we looked at the impacts at 2 different levels of deployment. One, a high level of deployment consistent with the higher ranges that are coming out of many of the global models, but also under a more modest level of deployment, including the assumption that land is managed sustainably. So the first of these 4 options that we looked at were bioenergy and bioenergy with carbon capture and storage, and BECCS as it is known. And just to remind you, once of all, if you see a blue colour, it broadly represents a positive impact, and if it's orange, it represents a negative impact. And the more intense the colours, the larger the impact that we're talking about. Now, for bioenergy and bioenergy with carbon capture and storage, at the high level of impact, the first line there, we're assuming that this removes 11 gigatons equivalent of carbon dioxide. So this is a very high level of impact. And we can recall also that bioenergy does not need to necessarily to be associated with carbon capture and storage. It also could be used on its own. And the big negative impact here, potentially here at high levels of deployment, is on food security. And some of the modelling numbers indicated that there could be 150 million more people at risk of hunger under that high level of deployment. Also potentially smaller impacts in relation to adaptation, with a population of less than 1 million affected. We did identify that there could be effects on desertification and land degradation, but these impacts are unquantified, hence the hatching in the picture there. But restricting the use of bioenergy to marginal lands or abandoned cropland, there would be negligible effects on biodiversity and food security, and potentially benefits in terms of combating desertification and other forms of land degradation. I should flag that in the top right-hand corner there's some dots representing the costs of the response option. 1 dot represents something where the cost of mitigation is less than $10 per tonne of carbon dioxide equivalent. 2 dots represents between 10 and 100 dollars per tonne of CO2 equivalent, and 3 dots represents an expensive measure that would cost more than $100 per tonne of carbon dioxide equivalent. Now, turning to the second option, which is reforestation and forest restoration, the top line here is based on the assumption that there are 10 gigatons of carbon dioxide removal altogether. In this case, there are positive impacts in terms of adaptation and combating desertification and land degradation, but again a negative impact at this high level of deployment for food security that could cause a risk of undernourishment for somewhere between 1 and 100 million people, depending on the scenario. At the modest scale, they would be co-benefits if they were using previously forested areas. It assumes small-scale deployment, the use of native species, and local stakeholder involvement to mitigate some of the risks associated with food security. Turning to the third option, which is afforestation, again, the top line, which is the large level of deployment, is equivalent to about 9 gigatons of carbon dioxide emission reduction, and very big impacts on food security for this option at this scale, with somewhere between 80 and 300 million more people undernourished. And it would also be the case that it fell out there that food prices could rise by up to 80% by 2050 at that level of deployment. At a small-scale, well-managed deployment, it could be used to prevent desertification and land degradation, and it could also enhance food security if it was deployed on degraded land, mangrove, or other land not suitable for agriculture. And the final of the 4 sort of big-ticket mitigation options are biochar addition to soil. This is assuming that this is deployed at a level that would give about 6.5 gigatons of carbon dioxide emission reduction. And dedicated biomass crops could use between 0.4 and 2.6 million kilometres squared of land, approximately 20% of the global cropland area. And this indeed could again, at this high level of deployment, affect food security for up to 100 million people.
But if done at a smaller scale, there could be moderate benefits for food security, including improving crop yields by up to 25% in the tropics. So we, again, at an appropriate level of deployment, that this could be successful. Abandoned cropland could be used for between 5 and 9 million square kilometres of land for biomass production without compromising food security. And the final point I would like to make on these 4 options, I've mentioned very large mitigation potentials. These cannot be added together. Land is a scarce resource and we can't use it more than once. So these are alternative ways of using the land. Now, I'd like to finish off this section by just a few slides that summarize some main points on the response options. And the next 2 slides especially apply to desertification and land degradation. We need to emphasize very strongly that response options are site and regionally specific. There is no one-size-fits-all solution globally. Activities that can combat desertification can contribute to adaptation, and they have adaptation and mitigation co-benefits, and they can halt biodiversity loss. Solutions that help us adapt and mitigate to climate change while contributing to combating desertification include water harvesting and micro-irrigation, using drought-resilient, ecologically appropriate plants, and agroforestry. And avoiding, reducing and reversing land degradation in rangelands, croplands and forests can help to eradicate poverty and ensure food security, so wider sustainable development benefits. In terms of degradation and desertification, again, reducing deforestation and forest degradation lowers greenhouse gas emissions and can contribute to adaptation goals. Sustainable land management can prevent, reduce, and in some cases reverse land degradation. And climate change itself can lead to land degradation, even with the implementation of measures intended to avoid, reduce, or reverse land degradation. In terms of desertification, there are technological solutions that are available to avoid, reduce, and reverse desertification, while also contributing to climate change action. Investment in sustainable land management and land restoration in drylands has positive economic returns. To exploit the gains, indigenous and local knowledge can often enhance resilience to climate change and combat desertification. And finally, preventing desertification in the first place is much preferable to restoration of degraded land. Now, my final three slides all relate to the food system. This first slide relates mainly to issues about energy supply and production. The total technical mitigation potential from crop and livestock activities and agroforestry is estimated at 2.3 to 9.6 gigatons of carbon dioxide equivalent year by 2050. The technical mitigation potential of dietary changes is estimated at up to 8 gigatons of carbon dioxide equivalent per year over the same period, and diversification in the food system can reduce risks from climate change. In terms of dietary choices, balanced diets featuring plant-based foods produced in resilient, sustainable, low greenhouse gas emission systems do present major opportunities for adaptation and mitigation, with significant co-benefits in terms of human health at the same time. But we have to acknowledge that transitions towards low greenhouse gas emission diets are influenced by local production practices, technical and financial barriers, associated livelihoods, and cultural habits. And final slide on food loss and waste. The food loss and waste accounts for up to 10% of total anthropogenic greenhouse gas emissions, and between 25 and 30% of food produced is lost or wasted. The causes of food loss and waste differ between developed and developing countries. In developing countries, it's a question of food loss before it gets to consumers. In developed countries, it's often waste at the consumer stage. So reducing food loss and waste can lower greenhouse gas emissions and can contribute to adaptation by reducing the land area needed for food production, which could free up land for other purposes. And technical options such as improved harvesting techniques, on-farm storage, infrastructure, transport, packaging, retail activities and education can all help to reduce food loss and waste across to the supply chain. Now that brings us to the end of the section on mitigation and adaptation responses, and if you will indulge us, we may be joined by a few of our authors who can actually help give justice to the challenging questions that no doubt you're going to put to us. Thank you.
Thank you very much, Pan Maranjai and Jim Ski. Sorry, thank you very much, Pan Mao and Jim. And of course, please bring some of the authors along so that we can draw on their expertise in our exchange with the room. And I'm struck by those presentations. The IPCC is famously not policy prescriptive, but I think everything you have given us is very policy relevant. And I think as we move forward to try and work out how do we act, I think there's a huge amount in there we should draw on, including these interactions, not just between climate change, clearly desertification, food security, wider sustainable development needs, and also I note in there the importance of some of these social choices we also have to pick on. With that, I would like to open the floor for a discussion. We have about 20 minutes or so that we can take. I'll take 3 questions, short questions first, and then go to the panel and the authors who can join in. And then I'll take a second round, I hope, before we finish. So I'll take Bhutan first.
Thank you so much. Bhutan would like to express our sincere thanks to SBSTA for organizing this very useful event and to the authors for detailing the special report findings. We sincerely hope that these findings will enlighten us to chalk out a plan to tackle the menace of climate change at this forum of UNFCCC. We again thank you very much for elaborating on the findings related to the adaptation and mitigation options. Could the authors specify what the role of reducing deforestation and forest degradation should be to achieve the long-term temperature goal of the Paris Agreement?
Thank you for that question. Next, I will go to Finland. Finland, you have the floor.
Thank you, Chair. Finland would also very much like to welcome the special report on land, which reminds us once again on the urgency of action, both for mitigation and for adaptation. Of course, not forgetting other sustainable development goals. The report also highlights very well the possible risks and complexities related to large-scale land-based mitigation. So thank you also very much for organizing this session, and of course for the engaging presentations. We do have a question. The report contains a selection of response options, which may, however, be to some extent parallel with one another, so the mitigation impact cannot be simply summed up. So we were wondering if you could give us an idea on what scale the land-based response options could contribute to the 1.5 or 2 degree target in total compared to the required global net emission reductions. Thank you.
Thank you very much. I will take a third question and then go to the panel. I'll give the floor to Colombia next.
Thank you, Mr. Chair. Colombia also wishes to thank SBSTA for organizing this special event and congratulate the IPCC for their very hard work on producing this special report, which is extremely valuable for all of us policymakers, particularly in countries highly reliant on land resources. On our question, we'd like to understand how the concept of carbon neutrality relates to land. The 1.5 report indicated that the world needs to be carbon neutral by 2050 if we are going to maintain warming up to only 1.5 degrees. However, from the perspective of carbon budgets, we'd like to understand whether this concept of carbon neutrality refers only to anthropogenic GHG emissions and removals, or if it also involves the natural GHG emissions and removal from sinks, whether in the accounting of carbon neutrality we should also include the natural non-managed land emissions and removals. Thank you very much.
Okay, we'll take those three questions first. The role of forests and meeting the long-term goal and how much land can do, and then neutrality. Jim?
Yeah, I can see that Joe House is anxious to come in on the first one. We will share them between us. If you could.
Yeah, I wouldn't mind commenting on all three, but obviously can bring in as well. So on deforestation and degradation, obviously forests are a huge carbon store, as are peatlands. And also, the terrestrial ecosystems currently contribute this natural service that the third questioner referred to, this natural sink service that's taking up about a third of all of our anthropogenic emissions. So clearly protecting these high carbon ecosystems, both for their carbon storage and their carbon sink services, is critical, and we need to start doing that immediately. As well as the carbon benefits, obviously there's other things like biodiversity, flood protection, rainfall recycling. There's a lot these forests and these other ecosystems do for us. On the role of land compared to other sectors, it can be much or little depending on how much you do in energy. And that's the thing, the less you do on energy, the more you end up relying on land, and that depends on the different pathways you take. So some scenarios have less reliance on land and they have more immediate cuts in fossil fuels. Some have later cuts in fossil fuels, and then you end up relying on land a lot to do your mitigation. You know, maybe up to a third of the mitigation might come from land, but then we're talking about huge areas of land, for example, 750 million hectares in bioenergy, and that's where you start getting these massive impacts then on food security. On the carbon neutrality in the scenarios, carbon neutrality does relate to anthropogenic emissions and removals very clearly. So that the fact that the land is providing a sink service naturally is already factored in to those pathways and where we need to get at and when we need to hit climate neutrality. That's already taken account of. The climate neutral part is offsetting remaining emissions from agriculture and other places it's hard to decarbonize with sinks on the land that are anthropogenic sinks. Already taken account of natural sinks. So that neutrality is just about human activity on the land and in energy sectors and other sectors.
Yeah, I wonder also, since we have the world's expert on distinguishing between anthropogenic and natural sitting at the end of the table, whether Giacomo Grassi might like to say something about that.
Thank you. Well, as Joe said, the neutrality is measured against what is considered anthropogenic. As described in paragraph A33 of the summary for policymaker, there is a discrepancy in the approaches used by global models and country inventories in defining what is anthropogenic sink. Essentially, due to different scopes, different communities have developed different approaches to estimate what is the anthropogenic forest sink specifically. This has been acknowledged and the cause have been explained in the summary for policymakers, and we are working hard with the global modelers to reconcile estimates between models and countries so that the next report from IPCC, the global estimates for the anthropogenic land sink could be translated in a policy relevant message also for countries and as a possible input for the global stock take.
Thank you very much for that first round of answers to the questions. We're going to go for a second round. I have several requests for the floor on the screen already. I don't think we're going to be able to get through all of them, unfortunately. And I would like to give the floor to somebody at the back from the observer community. I have no idea who's there. I can't see at all, but I gather we have a microphone. So we'll find a way of finding one person to come in the back. But before that, I'll give the floor to Ireland.
Thank you very much, Chair, and thanks again to all the authors and the co-chairs for all their work in delivering this really excellent and useful report. I suppose my question really goes to the some of the gaps that have been highlighted in the report. And one of them is I suppose, the limitations of top-down modelling to capture the bottom-up responses. And it's highlighted that the bottom-up responses can deliver a lot of mitigation potential. I was wondering, have any of the authors' views on how to address those gaps in terms of processes, and perhaps even how could the work of SBSTA help in addressing those gaps?
Thank you very much for that first question. I have one request for the floor from the back of the room from youth, and I'd like to take that question now, if we could, please.
Thank you very much. I appreciate the group coming together. Thank you very much to the chair and to the distinguished members of the IPCC for their time and speaking with us. We wanted to ask about, again, section B. The co-chair, you actually mentioned, or I believe it was one of the IPCC members, that land is scarce and that we cannot do all of these policies. Would that be a suggestion that pursuing a blend is either not possible or less likely? And in that scenario, what would you offer to states and organizations beyond a cost-benefit summary to suggest which of these solutions might on aggregate offer the most efficient way forward, noting obviously regional differences? We also would be remiss if we didn't ask about question A, about section A, specifically on permafrost. Under the graphic, you explained that the risks to humans and ecosystems from permafrost are high, but those are the only two risks that were associated systems-wise, and it was not actually human health that was listed. I'm just curious why the report didn't consider human health a risk with permafrost melting, given the abundance of old bacteria hidden within permafrost that may suggest global public health risks of disease epidemics. So did the literature not suggest this, or does the IPCC believe that this might not be a high confidence result? Thank you.
Thank you for those questions. Obviously, we're now focusing on this particular section, but it's noted. I'll give the floor to Egypt.
Thank you, Chair. Let me join my colleagues in thanking the authors for producing such an important summary for policymakers in front of us. I have two questions and a comment. The first question goes for the mitigation for carbon soil. What was exactly the time frame was used in measuring? Is it was 2 years or 10 years? The second question was referred to the loss in developing countries for food supply and the waste in developed countries. What was the main drivers for that? Because definitely we should take countermeasures in order to reach SDG 2. So this was an important issue for us as well. The comment that I would like to say that Egypt got its own initiative to bring synergies between Rio Conventions, and in this regard we will prepare for a meeting, workshop on the expert level that it will take place in the first half of the coming year to bring the authors from the IPCC and the IBBS and other relevant institutions as well to feed into the post-2020 biodiversity framework. This was my last comment. Thank you, Chair.
Thank you. There was quite a few questions. I suggest we pick those up now, and we may even have time for a final round.
Yeah, I think the authors will want to pick up some, but can I just start on the top-down model question? And just to say, the integrated assessment modelers are not with us today because they're all at their international consortium in Yokohama, so we can talk about them behind their backs quite successfully here. It is very clear that many of these integrated assessment models do not not take full account of all the possible measures that can be applied in the land sector. They really cover the big ticket items that I covered in my section of the talk. But they don't cover the other things. And I think the way they work very incrementally, improving their models. And I do think they are attempting to increase the coverage of these, and it's in different models, but they still have some long way to go. So in interpreting the output of the integrated assessment models, we really need to be quite careful about that. I might say from my own experience, it's also the case that at national level, we don't necessarily measure these emissions properly and incentivize farmers in the right kind of way, which is why many of the good things that Panmao talked about actually don't get taken up. On the question of land as being scarce, I mean, the authors may be better on it than I am, but I think that the strong message we got out is everything is regionally specific. And I don't think it would be right, actually, to produce a top-down answer globally that said this is what should be done. Stakeholder engagement and understanding the possibilities at the local and regional level, I think, are going to be incredibly important. But it is very clear you cannot add all these numbers up. There will be a blend of different measures, and it will be the use of measures will vary from one place to another. Well, I think I'll pass over to the authors at this stage who may want to fill up on some of the other points.
Thanks, Jim. Some really interesting questions there. Just to add on the top-down models, yeah, there are some clear things that they don't include at the moment, like, for example, soil carbon sequestration and biochar. Models are developing and improving all the time, and really they're there asking an exam question about how you force, what would the world possibly look like if we went for 1.5 and how might we achieve it. That said, I think when you talk about the difference between these top-down model analysis and what's coming up from the ground, I think one really big issue at the moment and where the science is really evolving, and you asked about where the gaps were, Frank, that's really around what's a realistic potential. So, what could we actually do? What's really realistic on the ground in these different contexts? Like Jim was saying too, and in response to the youth question, context is everything. So, what is really realistic on the ground? What would the farmers do? What would individuals do? How can we actually make this happen in a way that's fair? We talk about just transitions for coal, but also just transitions for farmers and land managers. How this can actually be achieved in a just way is a key issue. And then continuing with this issue of what we need to do on land and what's the best option. Because of this context specificity, it's a matter of laying out the options and then different countries seeing what's suitable within their context. And Jim rightly says you can't add all those bottom-up options up. That's what the integrated modelling lets you do. It lets you compete with the land. It lets you say, what if we put the land for bioenergy? Or if we don't want to have BECCS and bioenergy, then we end up with more forests. So what's that look like? But in the same sense that they do compete, some are also complementary. So some of those mitigation options actually free up land. So when you improve crop productivity, you free up land that can then be used for mitigation. So it's also looking at what's complementary, what can work together, how can you have agroforestry systems and other sustainable systems that work well together. And on Egypt's question on what's the time frame for those mitigation options, we looked into the literature for time frames around about 2050. So those are based on mitigation to be achieved by 2050.
I think there was one question last about food loss and waste. So if I do that very quickly, in developing countries, it's largely that's food that's rotting on the way to market. So questions like around food storage and refrigeration would be the way of addressing for it. In developed countries, quite frankly, it's breakfast buffets and people not finishing all the food on their plates, if I can put it that way. So that's a very simple, non-scientific way of describing it.
I now feel very guilty about my breakfast, but I should do. We've got 5 minutes, so I'll take 2 very quick questions and have 1 very quick round, and then we'll move on to the final part. And we'll come to the nearer term in the final section as well. I think that's important. First of all, I'll take India, then I'll take a question from environmental NGOs. So India first, please.
Thank you, Chair. At the outset, let me begin by thanking you for starting this very useful dialogue. We also had the Earth Information Day, and all this has been a very useful exercise. So please accept our compliments for starting this dialogue. At the outset, let me also compliment the authors for their very hard work. We were there at the plenary when this report got approved. Now, this is the platform, Chair, you have provided us for some kind of introspection of what we have done and what needs to be done further, because that is how the science progresses in the world. Chair, I won't exceed my time limit of 2 minutes. You may like to cut me off if I do that, but hear me very patiently, because the world has started asking the individual from the youth whom you gave an opportunity to speak was asking about options, and so will world demand options for fixing the problem that we are in today, because the whole world has been put in a jeopardy by the developed nations. We are into IPCC. We know that it is not policy prescriptive, it is policy relevant, and it is in that backdrop I ask 2 quick questions. One is that your report is having overemphasis on mitigation, very little on adaptation. 2 are not the same, and your own 1.5 report does not imply that 2 are same. The other quick point is, in this report, we have flogged the horse of nature-based solutions and drawn attention of the world on forests and agriculture. They are being increasingly portrayed as mitigation solutions. Forests, Mr. Chairman, through you, I want to share with this audience that forests and trees are not just dustbins of CO2 of the developed world. They are revered, they are worshipped. People live on them, derive their livelihood, sustenance, and so on. So, similarly, agriculture is done by small people in developing countries. There are no monopolists to be disciplined. The agriculture is not the same as in industrial countries. With this difference, I want to close my intervention, Chair. I see you are getting impatient, but I'll take half a second more to say that the Mother Earth or land, it is the place where we are born, where we live, where we perpetuate, and ultimately we mingle with this earth. So just a very routine, mundane treatment and not humanizing the whole thing may not be the right way. And now we should not put the burden of industrial, transport and service emissions of developed countries to those poor farmers or to those countries which are holding on to these forests with lot of care. With this, I close my intervention and thank you for your patient hearing.
Thank you very much. I'm not impatient. I'm simply making sure that we get through, but I think you made some very important points and questions. I will give the floor for a very brief question from the environmental NGOs, and then we'll have a very quick response from the panel, because we do have to move on to finish the final section. I'll give the floor to the environmental NGOs.
Thank you, Chair. I have a very quick question from the Climate Action Network group focused on ecosystems. Thank you for this extremely important report. You highlight the impacts of large-scale mitigation options such as bioenergy and BECCS and biochar on mitigation, adaptation and food security. But we didn't hear much on the likely impacts on biodiversity. We know it's not possible to address the climate crisis and reach 1.5 without addressing the biodiversity crisis at the same time. So grateful if you could expand on how the biodiversity impacts of these measures have been considered. Thank you.
Thank you. So adaptation, the burden and the impact on people's real livelihoods in agriculture and forests, and also biodiversity. Very quickly, please.
Yeah, just to say, we have discussed these issues many times with our Indian colleagues, and I think I was going to take these as comments rather than questions, with which I would not want to take dispute with anything that's said there. It does raise the broad issue which we addressed in the previous round about the link between the top-down perspectives and bottom-up grounded responses that take account of local conditions. On the Cannes International point on biodiversity, one of the things that we were very careful to think about was that this report was done in the context of other work by other organizations like IPBES, and we discussed with them greatly, and we brought colleagues from the IPBES world into the authors team to help us on these issues. And I think we have partially dealt with it, but please do wait for the full AR6 report as well when we can comment these issues. We've not finished yet. This is not the end of IPCC for the AR6 cycle. And maybe Joe wants to comment.
Yeah, thanks. Yeah, I didn't even manage to finish writing this report before we were starting writing the next one, so please bear with us. India, thank you for raising those comments. Couldn't agree more. And the point on biodiversity, I think there is a lot in the underlying chapters. I think in the summary for policymakers, what you're seeing reflected is that we were asked to focus on several key issues, being food security, desertification, degradation, and greenhouse gas flux. And that's why maybe there's not a lot of biodiversity messages raised to the SPM level, because that was really the steer we were given of where our focus was. There is more, especially if you look in Chapter 6, if you look within the desertification and degradation chapters. So please, if you're interested in those things, the same on mangroves, that issue raised up earlier, there's a lot on mangroves in the land degradation chapter, there's a lot. We've got stuff on mitigation and adaptation in mangroves as well across chapters 2 and 6. So please do look for the detail. We have some of what you might want to see in the full report.
So I'd like to thank Pan Mao, Jim, for your presentations, the other authors who have fed in, thank you very much, and for a very, very good exchange. It was rapid. I'd like to go further. I think it brings out so much about these interactions. I brought IPBES, for example, to present their global assessment in Bonn to SBSTA, and we clearly need to take on these issues also of justice and equity into our work when we move to policy side. And there. So now I will hand over to Ho-Sung, who will moderate the next round of presentations and the question and answer. And we're running still a little bit behind, but I think we're doing well.
Thank you very much for excellently managing this section, but section B, I believe. And now I'd like to invite Deborah Roberts to take us through this C and D, enabling response options and actions in the near term. Deborah.
Thanks so much, Ho-Sung. If we could go back to the slideshow. As the chair has indicated, what we want to do with sections C and D is call out some of the key messages with a strong focus on the policy options, and I'm sure many of you are interested in those in this room, but also to take some time to look at 3 alternative shared socioeconomic pathways which are analyzed in section C of the SPM. But let's kick off with the policy and think about policy design. What these two sections of our SBM highlight is that through appropriate design of that important triumvirate of action, so policy development, institutions, and governance systems at all scales, because we have to remember the interaction between land and climate impacts us both at the individual level, but it takes us all the way up to the international level, can contribute not only to our climate challenge, so adaptation and mitigation, but can also facilitate the movement towards development pathways which are much more climate responsive and climate adaptive. And this message about policy integration is a particularly strong one in this report. It calls out that mutually supportive climate and land policies have the potential not only to advance the agenda of climate challenges and responses and of land and the interaction between them, but have several co-benefits, for example, saving resources, amplifying social resilience, encouraging that important ecological restoration that prior speakers have underscored, and to foster collaboration between multiple stakeholders. So what we're really looking for when we underscore this importance of interaction is highlighting for policymakers that seeking out the right mix of policy options is a critical consideration in moving forward to ambitious action. And when we look at food and land policy, again we see underscored in the assessment the importance of policies that operate across the full food system. So don't only consider food production, food storage, but also consider issues we've already highlighted: food loss, food waste, the influence on dietary choices, and all of these have co-benefits in terms of enabling sustainable land use management, enhanced food security, and low emissions trajectories. And such kind of policies, so the more systemic approach, the right mix of policies that are appropriately integrated, contribute not only to our climate agenda, so again to both mitigation and adaptation, but help us address those important considerations of land degradation, desertification, poverty, and help us improve public health, which has already been called out by one of our commentators as an important concern. The adoption of sustainable land management and poverty eradication are important themes that run throughout the summary for policymakers, and these two sections call out factors that can enable progress in both of these areas. So, for example, improving access to markets, securing land tenure, encouraging us to think about customary access to land, and the access that women have in terms of access to land tenure. Very often women have constrained access to the ownership of land. Factoring in environmental costs into our food, using payment for ecosystem services as a tool, and enhancing local and community action. And again, these two sections of the SBM highlight how important it is in mobilizing people to draw on both local and indigenous knowledge. So as I say, this theme of integrated policy is key to these last two sections of the SBM, but is indeed key to the entire summary for policymakers. What that calls out is if we have a systemic approach to policy development, acknowledging that policies interact with each other, creating both co-benefits and trade-offs, by factoring that into the design of the policies, we can help overcome barriers to implementation. And that's an important advantage to have because implementation is about action, and we know that the Paris Agreement underscores the importance of action by all. Importantly, too, these two sections of the summary for policymakers underscore the importance of multi-level and cross-sectoral governance. It also underscores the need for policy development, which is flexible and iterative. And by looking at interventions at a multiple scale level, by ensuring that policies are developed in a flexible way, this offers us options of maximizing co-benefits and minimizing trade-offs. And why is this multi-level approach, this flexible level approach, highlighted in the literature as an important opportunity? It's because land management decisions are made at multiple scales. And we've just heard the input speaking to us about small-scale farmers and their issues. Literally, decisions are taken from the level of the individual on the small farm right up to the national level, so we have to think across all of those scales. And because, importantly, land and climate policies impact a number of agencies, they impact a number of departments. So this importance of vertical and transversal integration is highlighted in these two sections. And so really underscoring the importance of integration across sectors and scales is a real opportunity in the land and climate sector to maximize our co-benefits and minimize our trade-offs. But obviously, with so many decisions being made at so many different levels, with so many agents and actors being involved, involving people is an important part of the response options that this particular report calls out. And very often, the effectiveness of decision-making and governance is enhanced by the involvement of stakeholders, particularly local stakeholders, in both selecting our response options, in monitoring and evaluating the kind of policy instruments we use for land-based mitigation and adaptation. And this involvement implies particularly to the involvement of those who are most vulnerable to the impacts of climate change. And groups that are called out here are well known to us all: Indigenous people, local communities, women, the poor and marginalized. And I want to underscore the importance of women here, because this is a report which for the first time really calls out the importance of women in sustainable land management, in food security, and the benefits we get, therefore, from empowering women to improve action in both of those areas. I want to move on now to consider the three alternative shared socioeconomic pathways, or SSPs, that are looked at in section C, and you will see this in SPM figure 4. And essentially what this figure enables us to do is to look at the implications of mitigation and socioeconomics for land. And the report is, or the figure is divided into two components, component A and component B. If we look at component A, what we see is that we've examined here the influences and change in land cover due to different land management approaches over time. We looked at three particular pathways, and all of them were examined at the scenario of global warming of 1.5 degrees Celsius, or RCP 1.9. The second part of the figure, and we really don't expect you to be able to read these small figures up on the screen, but if you can, your eyesight is wonderful. We then looked at 5 different socioeconomic pathways, including the 3 looked at in section A of this figure. And for each pathway, we analyzed the change in land cover for each land type considered from a 2010 baseline relative to both 2050 and the end of the century 2100. And here we looked more broadly than at the global scenario of warming of 1.5. We also considered 2 degrees and 3 degrees. The types of land that were considered in this analysis are highlighted here for you. So looking at the change in natural land, the change in bioenergy cropland, and to be specific, bioenergy cropland refers to second-generation energy crops, the change in cropland, the change in forest, and that refers to both managed and unmanaged forest, and the change in pasture. The net result are these figures, and again, the detail is not important, but to call out some of the key elements of these socioeconomic pathways. The first is a sustainability-focused pathway. So here we have sustainable land management. Sustainability directs our agricultural intensification processes, and we are aiming for sustainability in both production and consumption. The net result is a good one. We need less land for agriculture, even though our per capita consumption increases in this pathway, which means we have options, and we can use this land for afforestation, reforestation, and bioenergy. And if you look at the figures in the graph below, you can see in this scenario that the need or demand for cropland has decreased from the 2010 level by the end of the century on the order of 5 million square kilometers. The need for bioenergy crops is up at about 4 million, over and above that in 2010 by the end of the century, and we see forest use, or forest land, up at about 7.5 million square kilometers. The second socioeconomic pathway is more middle of the road. Here our societal and technological development mirrors much more our historical patterns of development. And so what we see is an increased demand for land-based mitigation. So the use of bioenergy, reduced deforestation and afforestation. And that begins to compete with the need for agricultural land. And here, if we look at the need or increased demand for bioenergy crops compared to the 4 or so million square kilometers in our sustainability scenario, we can see the increase in demand from 2010 by the end of the century is up to about 6.3 million square kilometers. The final SSP that we looked at is a resource-intensive one. Here we have resource-intensive consumption and production, a very strong increase in our baseline emissions, a very strong reliance on technological solutions to our climate change challenges, including substantial reliance, as Joe has indicated, on bioenergy and BECCS. And that results in an increase in the competition with agricultural land. And so we can see here the demand for bioenergy crops is up to about 7.5 million square kilometers. So the really big message behind these graphs and looking at these socioeconomic pathways is the fact that anything that puts increased pressure on land, so the increased demand for bioenergy and afforestation, is going to create risks for society in other areas, such as food security and loss of biodiversity. So it's clear from the examination of those SSPs that we have choices. But what this SPM and these sections particularly underscore, particularly section D, is that there is no impediment to us beginning to act now. We have enough knowledge to act in the near term to address important concerns in the field of degradation, desertification, and food security, while at the same time supporting our longer-term goals of climate change mitigation and adaptation. And the kind of areas where we can take this near-term action are called out as options within this section of the SPM. So, for example, building individual and institutional capacity. Again, this is something important to underscore because this report also underscores the importance of education and training as a really critical way of building capacity, of increasing sustainable land management and reducing land degradation, of increasing that knowledge transfer among sectors of society, enhancing technology transfer, something that is well debated in these halls already, improving financial mechanisms, ensuring financial flows support women and their important activities in managing the land and increasing food security at the family and community level. Importantly, it calls out early warning systems as an opportunity to act to reduce risk, the need to undertake risk management, and to address gaps in implementation and upscaling. And so again, we get a very strong message emerging from these sections of the SPM that near-term action that addresses these range of considerations, adaptation, mitigation, desertification, land degradation, and food security, can bring us a host of co-benefits at the social level, the ecological level, the economic and developmental level. So that integration and co-benefit is a really important message that comes from these sections of the SPM. And importantly, these co-benefits service not only our land agendas, not only our climate agendas, but also help us to contribute to those bigger societal goals of poverty eradication and improving resilient livelihoods for those who are vulnerable and need assistance most. And so the two big take-home messages from these two sections of the SPM, and indeed for the SPM generally, are messages you've heard before, but I don't think they can be repeated enough. Firstly, rapid reductions in anthropogenic greenhouse gas emissions across all sectors, following ambitious mitigation pathways, reduce negative impacts of climate change on land ecosystems and food ecosystems. In short, land is important to us. If we don't act boldly with climate change, it will be endangered. If we do not act rapidly, if we delay climate mitigation and adaptation responses across sectors, This would lead to increasingly negative impacts on land and reduce the prospects of sustainable development. So through the perhaps inability or unwillingness to address climate change at an ambitious level, we will endanger not only the land, but our broader societal goals of sustainable development. And so at the end of the day, the big message is land is important. It can play a part, but is not a silver bullet to the climate challenge. So indeed, land with appropriate management can feed the world in a changing climate. It can provide biomass for renewable energy, but it cannot do it all. That's going to require early, far-reaching actions across several fronts, not only land. And with that, I'll hand back to Hussein.
Thank you very much for highlighting the importance of social, economic, technological, institutional, and governance factor that made all this transition possible. And with this, I would like to open the floor for discussion. EU, you have the floor.
Thank you, Mr. Chair. We join colleagues in welcoming the special report as an important and authoritative and timely scientific assessment. Today's special event is particularly well-timed as tomorrow, on the 5th of December, we celebrate the World Soil Day, which has been designated by the United Nations, which takes me to my questions. Could the authors elaborate on the potential for near-term action of reducing soil erosion, degradation, including the reduction of the drainage of peatland and organic soils? And how can these activities be best incorporated in mitigation and adaptation strategies? Thank you.
Thank you, EU. Iraq, you have the floor.
Thank you, sir. And many thanks for all presenters for this valuable report, actually. I wished to ask in the first part, but unfortunately I haven't the chance. But now regarding the social also, I think my question is have some connection with it. Many times mentioned that the Middle East countries is one of the most vulnerable countries regarding the climate change, and in the middle of the Middle East, actually, Iraq and Syria and other countries are the most affected and impacted, actually. So what I can report here that this valuable report focused almost on the natural relationships between each other, and also not reflected the unstable circumstances of some countries on the nature and in the end on the carbon emission. In our country, actually, as example for Iraq, we have in the last year very remarkable flood. In the year before, we have very remarkable drought, and also we have a big troubles with desertifications and dust storms and the very high temperatures, but still most of it coming from natural reasons. But the instability, the political situation also impacted very much and very high rate these areas. I can give some examples about this. When ISIS and Qaeda and this terrorist have the bad action in the country, in Iraq and Syria, hundreds of thousands were displaced from their original areas. And sometimes there is no places for them, and it is urgent. So for their needs, they depended on the land, the cutoff of the trees and so on, to provide the energy and their daily life requirements. And also some action of the terrorists, not only by the direct, they have some other actions, like they cut off the water from many governorates, and this lead to the desertification of the area, and this happened in some areas in Iraq and Syria. Sometimes they flood areas, sometimes they drought areas. And also these people, these terrorists, sometimes they invest the oil fields with very, very methods and technology which is not taking the environmental issues in hand. So finally, I wished if the report emphasized and focus in the future, we can enrich the relationship between the peace and the carbon emission, and we have a very noticeable maybe data and examples about this. Thank you.
Thank you very much. I'd like to recognize the Republic of Tanzania, and then I'd like to invite co-chairs for a response. Tanzania, you have the floor.
That might be you. Thank you, Chair, though this is the United Kingdom, not Tanzania, though I'd still gratefully accept the chance to ask a question. Thank you. First of all, can I just express my gratitude to all the scientists involved in presenting this very authoritative assessment, and also to those giving presentations today. We truly hope that the knowledge being presented can inform discussions throughout this entire process. I'd like to recall the figure that you presented, SPM4, in which the change in land cover was illustrated for different SSPs under, I believe it was RCP 1.9, and you mentioned that the same analysis was conducted for different temperatures. And in particular, I was wondering if you could comment on how these land use change profiles differ for higher temperatures, and whether you could comment on the impact of higher global temperatures on the effectiveness of the land-based mitigation options that lie behind those changes, in particular in the case of delayed climate action. Thank you.
Thank you very much for the very pertinent questions, and may I invite Deborah to respond?
So certainly I think in terms of the first question and the third, I'll leave those to the authors. But just picking up on the point made by Iraq, certainly I think what is underscored in these latter sections of the SPM is the fact that the kind of ambitious action that is required does require this integrated mix of policies and institutions and governance, which is obviously very difficult to achieve in places of the world beset by security issues. And I think it really, the example you gave us helps underscore the importance of stability and peace as part of the response options. But also to call out, because I think you laid a challenge down for us to think about these things as we move forward, and certainly in terms of the work that Working Group 2 is doing in terms of its main assessment report, these kinds of issues have already been highlighted by governments in the outline, and so it's likely that we're going to shine more of a light on these issues in the main assessment report.
Thank you. Zimbabwe, you have the floor. I'm sorry, yeah.
Hi, thanks. I'd like to address questions 1 and 3. So the EU asked about the potential for near-term action about soils. So we did look in quite a lot of detail in soils in the report. For example, emissions reduction from soil sequestration in croplands and grasslands each represent about 7 and about 2.5 gigatons of CO2 equivalent per year. and peatland restoration around 1. So that, it's quite hard to measure what's going in the soil, but it's clear there's a lot of potential. And again, coming back to this point about peatlands, they're also a huge carbon store. So what we can do to protect those peatlands is really critical. But also wanting to again touch on the fact that it's not just about the carbon. When you improve carbon in soils, you also improve nutrient retention and water retention. So then it's really important for adaptation as well as mitigation, coming back to India's point. So what we do on the soil, it might not be the big numbers, the big kind of removal numbers that you have with afforestation or BECCS, but there's a range of benefits from dealing with soil carbon. And on the question from the UK about land use profiles and how they differ for higher temperatures. So actually, in a sense, within those different temperature profiles, you can, at any temperature to mitigate to, you could rely more or less on land depending on what you do with the fossil fuels. In the higher mitigation scenarios, you do end up relying more on land in particular because you need those negative emissions. And the negative emissions technology in those models is BECCS and afforestation because that's what we know we can do now. So the higher mitigation ones tend to have more BECCS and afforestation, but even some of the lower mitigation ones still have quite a lot of BECCS and afforestation. And on the question of how we consider climate impacts on land, those models currently they're not sort of interactive, so they don't have interactive climate effects on the model. So they don't really consider the climate impacts on land in terms of thinking about where you might be restricted to grow in the future. But there's lots of, the climate models that have run and vegetation models show that there are both benefits and disbenefits in the short term from climate change. So obviously higher temperatures in some places will be beneficial and longer growing seasons and CO2 fertilization, whereas in some places already climate change is clearly really having negative impacts on land. So in the near term, you have some winners and losers, and hence you're getting these areas that were talked about earlier where you've got greening, and other areas where you've already got browning, so increase in vegetation and loss in vegetation. But going out into the future, all areas experience more negative effects from climate change.
Thank you. Zimbabwe, you have the floor.
Thank you, Chair. I would like to thank also the IPCC for producing this special report, which is very critical in addressing and understanding the impacts of climate change on land, as well as the contribution of land in mitigating the impacts of climate change. Chair, as Zimbabwe, would also like maybe to emphasize the need to acknowledge the special circumstances of countries. And as previous speakers have mentioned, that some of the response options or actions that have been noted, they are regional and context specific. We see this as very important, especially for Africa, to take note of the special circumstances of Africa. Some of the options which have been mentioned, the relevant options which have been mentioned in the report, we have observed some challenges. Take, for example, with hydro in parts of Southern Africa, which is our main also source of energy. But we've since realized it's quite vulnerable to climate change. Hence, as we come with these recommendations, which may be policy relevant, there's maybe need to further look at the possible limitations of some of the response options, because these are some of the drivers of deforestation and land degradation, which needs to be solved. The issue of energy and appropriate energy and some of the limitations, they need to be looked into closely. Otherwise, it will be very difficult to arrest land degradation and deforestation. I submit. Thank you.
Thank you very much for a very, very important question, very, very important comment. Estonia, you have the floor.
Estonia would like to join the previous speakers in welcoming the IPCC Special Report on Climate Change and Land as an important, authoritative and timely scientific assessment. We thank the scientists involved in providing this report in support of the work we're doing here at the UNFCCC. We are pleased to see that the report complements the IPCC's 1.5-degree report, special report by adding detailed information on land-related issues. And here comes my question. Could you please elaborate on the use and the potential of the bioenergy with or without the use of carbon capture and storage in the pathways that we saw presented? Thank you, Chair.
Thank you very much. At this point, I would like to, may I invite Deborah to provide responses, please.
Thank you, yes, and I will refer the query from Estonia back to the authors, but certainly in terms of Zimbabwe's comment around the special circumstances of regions and countries that have to be considered, I think that's noted and underscored in this report, and certainly will be picked up again in the main assessment reports. These kinds of challenges obviously will be picked up specifically in Working Group 2 because of our strong regional focus, and the increased coordination between Working Group 2 and 3 hopefully will allow us to assess at the kind of depth that will give an increased view on these particular challenges with the main assessment report.
I would like to invite authors to add on this comment, please.
Yeah, regarding the question about energy challenges in Southern Africa, I think the speaker from Zimbabwe raises the important issue that in this region, water is more the constraining factor than land. And this is discussed in the report, and I think that a key message of the report is that the flexibility to rely on different renewable sources and the flexibility for different land management policies and approaches, and integrating these approaches can help to reduce this vulnerability, at the same time addressing, as the speaker notes, the crucial issue to improve energy access.
Thanks. I'd like to talk to Estonia's comment on BECCS. I'm not sure elaborate in which way, but let me have a go, and then if I don't cover what you want, you can always grab me in the corridors later. Wow, bioenergy was really controversial, as I'm sure it doesn't surprise many of you. I think we probably responded to more author comments on bioenergy than any other topic, at least in the chapter I was involved in. And I think part of that comes down to this issue again about how context specific it is. And even when we were trying to talk about what do we mean scale, but it's not just about area. So for example, you might have bioenergy that covers quite large areas but isn't having the same impacts, for example, using residues of sugar production for ethanol. Actually, that's quite a large area of sugar production, but it's using the waste. On the other hand, you could have quite small-scale bioenergy production, but if it's causing deforestation, like for palm oil, for export, as an oil crop for biofuels, then that there doesn't need to be a lot of that to cut down forests and have a negative impact. So these were some of the issues we were dealing with, and where we tried to really look through the literature to really be clear about where the positives were, where the negatives were, and what you needed to be really careful about. There are scenarios with the IMs that look at not having BECCS, but as I said earlier, that means that you need to reduce emissions from fossil fuels very rapidly, very, very soon, because if you don't, then you end up relying on BECCS. And given that the carbon capture and storage technology is still really at demonstration phase, that seems maybe not something you might want to rely on. I hope that helps and answers.
Thank you. It's very helpful. I'd like to recognize Singapore. You have the floor.
Thank you, Chair. We congratulate IPCC in producing this special report on climate change and land, and also thank SBSTA for organizing this special event. My question should have been raised in part one, but it might also be appropriate here in regards to action in the near term. It is mentioned in the special report that fires is the natural part of Earth's geological past and its biological evolution since millions of years. And it is also indicated that presently humans are a cause of fire ignition, whereby the special report also highlighted that human activities have become the dominant drivers now. For example, trends in burnt areas in Southeast Asia witnessed an increase since 1997. We note that forest fires, wildfires, or from human activities in natural forests or agricultural lands would have many impacts, including on biodiversity, human health, and a reduction in carbon sinks, among others. Would IPCC be able to highlight with the level of confidence the linkages of such forest fires, in particular fires from human activities, and its association to climate change and the detectable risk to regional air quality, increase in mean air temperature, human health, and biodiversity loss? And what further response actions in the near term can global community do to address any gaps in implementation to reduce such activities? Thank you.
Thank you very much. India, you have the floor.
Thank you, Chair. I just wish to draw attention through you of the audience, distinguished participants, that the solution being projected, portrayed through bioenergy may not be all that simple. This would need to be seen in a socio-economic perspective. And the perspective, Chair, is that we have hunger, malnutrition, and we are, while trying to coax the limited land resource to produce enough food to feed people, it is in this perspective that we need to appraise the solution that we are projecting. The synthesis report, Chair, is out now. The synthesis report of Annex 1 countries. And it is very clear that between 1990 and 2017, developed countries have been able to reduce their emissions only by 1.6%. Now, if you say that bioenergy crops have to be grown, and if they have to be grown in a developing country, see, thinking that those crops like jatropha and other bioenergy crops can well be grown in developing countries, then this would seriously compete with the food production ability of the land, finite land resource. So, do we not need to think whether this solution is something which is doable, feasible, achievable, implementable? Having said that, I would again wish to thank the authors, and I go down the early memory lane where we had the woman power who is now on the podium, also on the podium at that time, and the consensus atmosphere that prevailed while adoption of the report was largely due to their able chairpersonship. With these words, I'll close my intervention by only reiterating the point that solutions that we are now portraying, that these have to be done, I am not saying that they may be wrong. What I am trying to say is you have to appraise them
in the light of the available socio-economic conditions in the world, whether we are burdening those farmers who are small, marginal, and who are the condition in the developing countries. Now we are asking them that you also produce for the ill effects of climate change, you produce bioenergy crops to save our brothers and sisters from the developed countries? This is the question. Thank you.
Thank you for the question. And indeed, the socioeconomic factors is the key critical component whether we can have a real solution. Thank you. With that, I would like to invite co-chairs to provide responses.
I will refer Singapore's question on fires to Valerie. We shouldn't, no? Yeah. Okay. Joe can do fires. Great. Joe, you can do fires. But perhaps just to underscore India's point, which I think reinforces the point made by Zimbabwe, that thinking about impacts at the local scale is really critical, that issues of equity and justice are important considerations. And again, those are important messages we brought forward from the special report on 1.5. The kind of trade-offs I believe Jim and Panmao highlighted in their presentations of Section B, which calls out the fact that there are tough choices to be made. But we need to bring those choices to the table always through the filter of sustainable development and equity and justice. So, Joe, fire.
Thanks. We have a box in Chapter 2 on fire, so please look in there for more detail, but to cover some of the key points of that. The fire weather season has lengthened globally between 1979 and 2013, although there's a fairly low confidence statement for us. Actually, the area burnt has decreased, mainly because of less burning in grasslands and savannas that may be more associated with them being used for croplands now. What we found in the literature at the time of doing the report is that drought remains the dominant driver of fire emissions. But what's interesting is an increase in fire frequency in places that aren't so common to have fires. For example, in some tropical and temperate regions, even during normal to wetter than average years, we're starting to see fires happen due to the warmer temperatures that are increasing the vegetation flammability. And in the boreal zone, it's also experiencing larger and more frequent fires. And the expectation is this will continue under climate change. But there's a real interaction here between actual land use and fires. And what we often see is it's the land clearing and then the land clearing and vegetation left, and then fires happen then in the dry season in the areas where it's been cleared, and there's a strong association with land clearing and fires. And so it's often hard to tease out and to really attribute what is due to climate change and what's due to land clearing.
Thank you for providing us the clarity on that, and you have the floor.
I was going to comment on the other point from the representative from India, which is an extremely important point and is discussed in Chapter 7 of the report. The socioeconomics are fundamental, and particularly the governance of bioenergy, and as with any land-intensive activity, is crucial for equity and addressing competition. And it's also the case that when we look at the way we are using land and biomass today, of course we are using much more than we need to, both in energy and agriculture. So as our systems improve, we will have, if we do a good job, let's say, we'll have more land available. But at the same time, as the representative points out, this has to be done with due process and consideration for the local stakeholders. Thank you.
Thank you much. We can have the final round of Q&A. I would like to invite Fiji and Youth, and then Deborah for answer. Fiji, you have the floor.
Thank you, Chair. First of all, I would like to join others in acknowledging and thanking IPCC and SBSTA for this report and as well as for organizing this event. My question is, could the authors elaborate on the related SPM statement that the deferral of GHG emissions reductions implies trade-offs leading to significant higher costs and risks associated with rising temperatures? In particular, could the authors detail how high costs and risks would be from delaying the reduction of GHG emissions?
Thank you very much. The impact of delayed actions, and I would like to recognize the NGO youth. You have the floor.
Thank you, Chair, and thank you all the authors for the excellent work and for this event. My question is related to the social economical benefits of land. Are the assessment of the economical co-benefits on health system of land restoration considered into the report in the vision of health benefits of nature-based solution? Thanks.
Thank you very much. Thank you very much for the comment. Do not see any request for further intervention, and I'd like to invite Deborah for comments and answers.
So again, I'll defer it back to the authors, but just some high-level comments on the high costs and risks. I think the report is really clear that without ambitious mitigation and adaptation action, land, which the report clearly demonstrates is critical for sustainable development, its ability to provide us with the kind of services that have been outlined, such as food security and so on, will be damaged. And so the increased chances of risks and floods impacting on health, on food security, these would become issues where the high costs and risks begin to emerge. But I'll hand over to the authors on both health and the issue of costs and risks.
Thank you very much. I'd like to invite authors for comment.
Okay, so sorry, not so much my area of expertise, but in Chapter 6 we look at co-benefits and trade-offs across all the Sustainable Development Goals, and that does talk about health benefits of land restoration and nature-based solution. It wasn't one of the key focuses of the report, but it's definitely considered in there. So again, please have a look at the underlying detail.
Regarding the change in risk and how these risks are managed, I think a key issue in terms of risk management is the increasing unpredictability at higher temperatures. And so one approach that's discussed in the report is adaptive management to risk. And so I think it's the unpredictability at higher temperatures also that plays a big role in the concern.
Thank you very much. Before I hand back to Paul, I'd like to briefly summarize his presentations and comments from the floor, questions and comments from the floor. This has been a very, very productive session for IPCC, and I hope to you as well. And this is the good example of science and policy interface. We can confirm that land is under growing pressure, and land is part of the solution, but land cannot do it all. We should search for ways to maximum the utilization of adaptation and mitigation options that would have least adverse impacts on ecosystems. And to achieve that, we need to have an appropriate governance system, institutions, and other societal arrangements to achieve goal. There are many productive and insightful questions from these about these presentations. I can group those questions into some broader themes, but I see that there were a couple of questions about the methodologies, for example, about the top-down and bottom-up methods, and as you imagine, those questions are more or less a perennial ones, that the science community has to deal with. And we found that we need a deeper understanding on the impact on the livelihoods of people, as well as deeper understanding on the ecosystem disturbance. And clearly the impacts are a function of climate change, as well as a function of the non-climate variables. Many times it is not easy to differentiate the impacts from these two very, very important variables. Now, we need to improve our understanding about the regional impact, especially to understand precisely more about the limits to adaptation. But to improve the limits to adaptation, again, we must have better understanding about the importance of socio-economic aspects of this matter. As often mentioned in a number of interventions, we noticed that the bioenergy solution must have very keen focus on the importance of socio-economic factors. And many of these questions and comments will be a very, very important inputs to assessment of our main reports, which are currently underway. Thank you again for your interventions and suggestions, and this will make IPCC healthier than ever. Thank you very much. Paul, you have the floor.
Well, it comes to me to close the meeting, and I want first of all to thank the IPCC collectively. Ho-Sung, of course, is its chair, Deborah, Jim, Banmao, Hans, Valerie, as co-chairs of the different groups, and the other many members of the IPCC who have been with us today, the authors who've taken part. Some of the others I've seen, I did see Yuba and Telma sitting down before. They seem to have left, but I know many other contributors to the IPCC work have been with us. So I want to thank you all for all that you've done in this report. Of course, in the other reports, the 1.5 degrees report will come tomorrow to the Ocean and Cryosphere report, and I'm very conscious that this has been a non-stop period for the panel as you produced 3 enormous and very important special reports whilst getting the full AR6 fully underway, and we're very much looking forward to that in only a year and a half or so away. So I haven't done the calculation, I'm doing it in my head, but soon. And it's real time for you all. So many thanks to you for all of that. Many thanks to everyone for their contributions to today's discussion. It's hard to have a truly interactive discussion in a room this size, but I think we had a good exchange, a rich exchange, and I think it brought out very clearly that we need to use the information provided by the scientific community, particularly as it's been synthesized and provided to us through the IPCC. But of course, the wider, all the individual research that comes through, this is where we need to develop our policies as parties to deal with the impacts of climate change. And I think the whole question of adaptation, vulnerability came through very strongly in this area. The links to loss and damage also came through. And of course, in acting to transform our economies and our societies, the links to justice, the links to development, and of course the multiple links to the wider sustainable development agenda, not only to tackling desertification, land degradation, food security, but also the links to biodiversity we touched on, and many other areas. Water, of course, came out in many times, and I know that is central to this area. So I wanted to thank you very much for all of that. We will have a further discussion tomorrow in the same format, but this time looking at the special report on ocean and the cryosphere, and I look very much forward to that. And in terms of a follow-up to today's discussion, first of all of the presentations will be available on the webpage. You can find it on the UNFCCC website. As always, it's never easy to find, but if you follow about 6 different links you can get to it. One of them should be through the science links with the IPCC, and then you will find a direct link to this, but we'll make sure you can find it. And then with Hosong, we will prepare an informal summary report, which will be prepared under our responsibility, our joint responsibility. That will be early next year. To produce a good report of this discussion will obviously take some time, but I hope early next year. And that will be well in advance of the next session of SBSTA 52, in June next year. And that also will be made available on the UNFCCC webpage. With that, I want to thank everybody for their participation. The IPCC, once again, for its support, the support the Secretariat gave us in preparing this, and of course all the authors and chairs in taking part. So with that, I will declare this special event closed and look forward to seeing you tomorrow to talk about ocean and cryosphere. Have a good evening.